Good morning. Good morning, yeah. Feel free to respond a little bit. I'll start with just a couple of housekeeping items, if you will. I'm going to sort of go on a little journey with you this morning through e-commerce and AI. And we'll talk at a couple of points along the way. There will be maybe some discussion. But if you have any big questions that are sort of not related to the topic at hand or the discussion point at hand, I would ask you to save those to the end if you don't mind, because it'll just be easier to kind of go down the path, and I may answer it along the way, your question. But we should have plenty of time for questions at the end. This is designed to be not fully interactive, but somewhat interactive. And if you just can't hold that question in, please just let me know and ask it, and we'll address it at the time. So I'll tell you a little bit about myself. By the way, this is what ChatGPT thought it was going to look like today when I asked it to make a picture of a room full of UNT Eagles and me speaking before them. As you can tell, we have almost exact same physique as the guy in the picture. But I'm a software developer. I've been in that business for quite a while now. I started the company Risoyo in about 2009. But I grew up in Wichita, Kansas. I was born there, grew up there in Wichita, Kansas. I got my undergraduate degree from BYU in Utah. And then I got my graduate degree from a place called Bocconi, which is in Milan, Italy, in 1991. So I was there during the first Gulf War and the fall of the Berlin Wall. So it was a very interesting time to be in business. And my first assignment right after that was to help a German company expand in Europe, because it was also the same time, 1992, 1993, when the borders went down in Europe. I don't know if you've ever traveled to Europe, but when I first went to Europe, you actually had to go through customs when you went from like Italy to Switzerland to France, et cetera. But obviously, if you've been there, you would know you don't have to do that anymore. Probably makes me sound really old. I was not alive during World War II, just in case you're asking. I have been married for almost 37 years, and this poor woman who had the great misfortune to marry me went through a lot of change in the first years of our marriage. We went, the first 11 years of our marriage, we moved 10 times, or maybe it's the other way around. And when we moved to Texas, we decided that we were just going to stay here because she was done moving. So I've been here ever since. I have a son who graduated from UNT. He actually graduated in radio, television, and film, but he studied computer science and economics as well, and he's now our chief technology officer. And I have 3 wonderful little granddaughters from him and from my daughter. But my wife and I, like I said, we met in Italy, and I worked through a number of large companies initially. I worked for a German company, which is now a division of Bosch. I worked for PepsiCo in both the restaurant and the Frito-Lay, or the snack foods division. And I worked for a large, what do they call it, direct selling company that was throughout the US, Europe, Asia, and I spent a fair amount of time with them, and that was where I was introduced to e-commerce. So while working for that company, I developed my first e-commerce store. That's what we called them back then. But I didn't like it that much, because one day I just rage quit. And I sent my boss an email. It was nice. I didn't use any profanity or anything, but I told him I was leaving. I got up from my desk, got in my car, figured out how I was going to explain this to my wife, and then drove home and have not been back to that company since. Pro tip, it's probably not the best way to quit a job, so if you're doing this in the future. But I have to admit, it felt really satisfying at the moment. And that was how I got into e-commerce, was I rage quit my job and I became an entrepreneur almost by definition. So at that point, my future was a blank page. And I got into a business where we were selling these discount programs for companies on the web. We used a very, very old system, no longer exists. It's called Pro Stores. It was owned by eBay to sell. Oh, you have the clicker? She's in charge of that. So we used that to sell these discount programs online. And soon we became the largest merchant on that system. And they were owned, Pro Stores was owned by eBay. eBay saw what we were doing, and they asked us to do some work for them. And just slowly, I became involved in e-commerce more and more. And we started helping other merchants create websites online. So that's about half of our business. And the other half of our business is also e-commerce related. We create custom applications, both SaaS and non-SaaS custom applications for companies that do a variety of things in travel industry and hotel industry. We also create and sell SaaS services for online merchants. And that's kind of the other half of Rosolio's business. But it's moving more and more away from the platforms and more towards the customization. And the customization area and the custom application area is where we began working more heavily with artificial intelligence. Can you move to the next slide real quick? So thinking of when I agreed to speak and they asked me to speak on artificial intelligence, I really didn't have anything written down. And I thought the first thing I need is a clickbait title. So I'm not sure how well it worked, but I guess it worked on you because you're here. So I thought the title seemed a little general, but it's rather, if you think about it, it's a kind of pithy, meaning it's like full of meaning, right? So it has 5 terms in there that are very loosely defined, and we'll talk about those one by one as we go through this. Can I get the next slide, please? Yeah. So I'm gonna, whoops. That X somehow it shifted when I converted to PowerPoint. It's in the wrong place. It should be on Utopia. So there is no utopian business. Let me just make that clear right now. That doesn't happen. When things get easier, they get easier for everybody. And basically that is the new base level for competition. So if you were looking for utopia from artificial intelligence, I don't think that's where we're going. Next, please. But let's talk about e-commerce. So who here, this is an intro to e-commerce class, right? Who here can give me a good definition for e-commerce? Go ahead, sir. Buying and selling of goods online. Okay, that's good. Anybody else? That was pretty succinct, right? Does everybody agree with that? Like that, if you were to have raised your hand, that's pretty much the answer you would have given. Okay, buying and selling goods online. Well, let's talk about that a little bit. So next slide, please. I think we should probably go back in time a little bit and figure out like when the first e-commerce was. So if I'm buying and selling things electronically through a network, if I buy and sell something through a phone network, is that e-commerce? Any thoughts? No? Okay. Because businesses have been doing that actually since the telegraph, right? We've been placing orders online or over electronically at a distance. It wasn't over the internet, but by the time that you or my age, we may be on something completely different other than the internet. Will there still be e-commerce at that point? Does it have to be the internet? I don't know. Let's go on to the next slide. So let me walk you through a scenario. I get an LL Bean catalog in the mail. Do they still exist? I don't know. I used to get them all the time, so it's the one I remember. I get an LL Bean catalog in the mail. I call their call center. They answer the phone. They select my product using an electronic system. I'm talking on the phone. They're on the computer. Their computer is attached to the internet. They then place my order. They take my credit card and clear the credit card transaction through their ERP system. And it's all shipped. So I'm still on the phone. Is that e-commerce? Did we broaden our tent a little bit going there? Okay, let's go to the next slide. I'm sitting in McDonald's, and I'm on my McDonald's app, and I'm so lazy that I don't want to get up from my table. So I place an order, I give them my table number through their app, and I make my payment online, and they bring me the food directly to my table. Did I just commit an act of e-commerce? So is all commerce e-commerce now? If I'm a convenience store or a pop-up store, have you ever been to a pop-up store? A pop-up store shows up at a game or whatever, right? And they're selling t-shirts or what have you, and they have that Stripe machine. That machine is connected to the internet, and you hand over your card or you put your card in the machine at that point of sale. Is that e-commerce? You didn't go online, but the entire transaction took place online. Where does e-commerce stop and where does e-commerce end? Let's go to the next. So let's read this one together. This is actually on Amazon's website. So if anybody should know what e-commerce is, it's Amazon, right? E-commerce or electronic commerce is the trading of goods and services on the internet. It is your bustling city center or brick and mortar shop translated into zeros and ones on the internet superhighway. No laughs? This is still on their website. Somebody at Amazon thinks that this is a sufficient definition of e-commerce when they do commerce in all kinds of different ways over the internet, right? I remember in the 90s when somebody would tell me or use the term information superhighway, which was sometimes how they described the internet, I thought they were running a scam. If somebody says it now, I just think they're a boomer, right? Is this a good definition of e-commerce? I don't know. Nobody, as far as I know, nobody at Amazon was fired for putting this on their website, and it's been there for like 15 years. I find it fascinating that they would define it this way because I think this has nothing to do with e-commerce, really. It's only a very small part of what happens in e-commerce. All right, next, please. So let's start from a different perspective, and let's try to define e-commerce in terms of the parties or players that are involved in e-commerce. So I'm going to kind of imagine the definition of e-commerce rather than like one succinct thing as more of something that we sense that has kind of fuzzy edges to it. So let's put some of the companies that would be at the center of e-commerce in the center of this slide. So Amazon, I think Etsy, Temu, Alibaba, I think we would all say these are companies who are principally engaged in e-commerce. Would we? Okay. So then, as we move closer to the edge, next slide, Uber, DoorDash, Lyft, are these e-commerce? Yeah? I think mostly, right? I think we would mostly say they are. Okay, next one. All right, what about Tinder, Candy Crush, apps that have in-game or in-app purchase? Are they e-commerce? No. Why not? But But a transaction takes place. They're selling your colleague here, who gave us our definition of e-commerce. What's your name? Isaiah? Okay. Isaiah said that it's the selling of goods and services online. So this is the selling services. It's kind of e-commerce, right? Yeah, it doesn't feel quite e-commerce. Maybe e-commerce adjacent? I'm going to say, and by the way, I've kind of misled you all. I've taken you down a path that was a bit of a trap, but let's go one more step closer to the trap. Okay, let me give you a scenario. And I'll speak about my wife in this case. My wife is the queen of Facebook Marketplace. She will sell anything. So I don't know if you know about getting old or have thought about this, but you go through periods in your life. And when you're younger and having kids, and like all my kids are moved out, I have grandkids now, et cetera, they come and visit. I just love it. But for all that time that my kids were at home and we were kind of building our house, we were acquiring things. Now we're getting rid of things. And one of the reasons that we're getting rid of most of our stuff is because my mother was diagnosed with dementia a couple of years ago, and we had to move her into this small memory care facility, and we had to go through all this junk, like we had to get rid of stuff, and I'm like, I don't want my kids to have to go through that. It was painful. So she started selling everything on Facebook Marketplace. Now, you advertise online, right? You're on Facebook. You sell to somebody online. You can actually get payment through Facebook. Nobody does, right? You can get payment through Facebook, but most people will pay Venmo, Zelle, Cash App, whatever, electronically, right? So is this e-commerce when my wife sells my old office chair for $160 on Facebook Marketplace? Yeah? That's e-commerce? You have a very broad definition of e-commerce. I'd like to think of our definition of e-commerce a little differently, and I'm going to turn it around, and here's where the trap is. So e-commerce is an activity. It is no longer a type of company. It's a type of activity. And almost every company of any size is engaged in e-commerce. So there are companies that have, for example, SpaceX has an e-commerce division. They have a director of e-commerce. I don't think we would say SpaceX is an e-commerce company, though, typically, right? So I want to think about, as we talk through this, I'm going to stick probably closer to this middle group when I talk about e-commerce. But I'm going to talk about stuff on the fringe as well as e-commerce. So there used to be a fine line, but now it's all digital commerce. And whether it takes place in person, or it takes place over the internet, or some other way, there's almost always a core digital component to a transaction and to the marketing of whatever you're selling, right? Next, please. All right, let's define this term. Now this one, we're going to have to go back in history a little bit to define, but what is artificial intelligence? Who wants to step into that sticky pile? What is artificial intelligence? Does anybody have a good definition for it? Any ideas? All right. Well, let's go to the next slide and we'll talk about it. So before I define it, I think we all have a sense of what it is, and we all have a sense that it's coming, right? And a lot of people have tried to define it all the way. Has everybody had a chance to read this? We'll read it together. Things happen fairly slowly. They do. These waves of technology, you can see them way before they happen, and you just have to choose wisely which ones you're going to surf. If you choose unwisely, then you can waste a lot of energy, and I might add years of your career. Then you can waste a lot of energy. But if you choose wisely, it actually unfolds fairly slowly. It takes years. So don't Google. Who said this? Anybody? And when? And what were they talking about? Anybody have an idea? Don't Google it. All right. If you don't know, Next slide, please. So do you know who Steve Jobs is? Like, I feel really old when I have to actually ask that question. But Steve Jobs made this statement in 2008. Any idea what he was talking about? He was talking about the smartphone. He wasn't even talking about artificial intelligence. That wasn't even on his mind yet. He was talking about the smartphone in 2008. But we're going to revisit this because I think you're going to see, and I'm going to make the case for this, that this presentation or this statement applies exactly in the same way to artificial intelligence and some other technologies that we're going to talk about. So let's go on to the next slide. So let's talk about, when I talk about artificial intelligence, I have a year in mind which I make for a dividing line. So, and that year is 1951, and we'll explain that in just a minute. But before 1951, I call it AI dreaming. There was a lot of talk about artificial intelligence. There were people thinking about it. There were papers written on it. There were research studies done. The U.S. government funded artificial intelligence proposals even before 1951. From 1951 forward, we've moved into a phase which I would call the artificial intelligence development phase. And this is where I think we really get to kind of the interesting part of it. But let's talk about what happened in 1951. Can I get the next slide, please? Or before 1951. So I'm sure you don't know what this is. But so this is a picture from a stage play called Rossum's Universal Robots. Anybody heard of this stage play? Rossum's Universal Robots. So this play was written in 1921 by Karl, and I can't pronounce his last name. He was a Czech playwright. And he brought to the English language, or actually to our modern language, the word robot. So this play was where robot came from. And the word robot derives from a Czech word for a type of serf, basically a servant or a slave. And the robots in this play were not necessarily mechanical. Somehow they were growing them chemically, I think. I'm not exactly sure how they put them together. But I would encourage you, like this play, there are versions of it that have been performed recently, and it's still up on YouTube. There are multiple versions of this on YouTube. I would encourage you to see it. And the reason being is that these robots had probably what we would call artificial intelligence, and they were evolving to what, and I hate this phrase, artificial general intelligence. I think it's a scam word, by the way. It's a word that's made up by people to deceive you. But artificial general intelligence is kind of what they evolve to, and they become very smart. And it goes over a lot of it thinks through, in this stage play, a lot of the problems and issues that we're dealing with right now. And that's why I think this is a great play because we're at the birthing of real artificial intelligence right now. And we're seeing all of these problems, and I'm sure you've heard about what's going on with Google in the news, their artificial intelligence, Gemini, et cetera. There's a lot of problems with this. And they actually thought through all these different things that would happen with artificial intelligence. And I won't tell you exactly what happens in the play, but I will tell you it gets violent between the robots and the humans at some point. So that was pre-1951. If we look at the evolution of computer technology prior to 1951, you'll notice that kind of around, in the 50s, we actually started to have some, computers, what we would recognize today as computers. They were, machines that filled entire rooms, et cetera. I've actually seen a couple of them. I was not alive in 1951. But I've seen them in a museum. And, before this, they were pretty much electromechanical machines. So they were machines that had motors that would, turn levers. And we had kind of the solid state relay period, if you know what electronics are. That didn't last very long. We went to vacuum tubes. You've probably seen vacuum tubes. They're popular, still used in amplifiers and things like that. They're wonderful things. And then, the transistor came about, and then things just started going crazy. And now we have the kinds of computers that we have today. But if you went back, prior to 1951, and you took out your phone, you had, I don't know, probably 20, 30 times more computing power than existed on the entire Earth at that time, right? It has evolved that quickly. And so the vacuum tube age was when we started getting people actually programming computers, and that kind of led to artificial intelligence. And there were two thoughts about how to achieve artificial intelligence or machine learning. They talked about teaching a computer to learn. That was the innovation of artificial intelligence at that time. So one was using a general purpose computer. You probably recognize this if you've seen the movie The Imitation Game. I think this was on the movie poster. But this was Alan Turing's machine. Anybody know who Alan Turing was? Offhand? Not much. So Alan Turing was a mathematician, a British mathematician who lived during World War II. And he created this computer, this electromechanical computer, that was designed to break the Nazi Enigma code. And they were able to successfully do that. I highly recommend you watch the movie. It gives a pretty accurate depiction of how that whole process worked. It's more about the life of Alan Turing, which was pretty amazing anyway. But this machine here was electromechanical. Now, I put this on here not because it's a great example of electromechanical computation, but because Alan Turing is a central figure in thinking about artificial intelligence. And by the way, we're still pre-1951. Can anybody tell me, has anybody here ever heard of the Turing test? Okay, one person. 2, 3, all right. So the Turing test was an idea that Alan Turing came up with as he was thinking, well, how can you tell if a computer is intelligent or not? How do we know if we've arrived at artificial intelligence? And he developed this game, or it's called The Imitation Game. The movie took the name from this actual thing, The Imitation Game. When he said, okay, I have a person C. This person C is communicating with a computer A and a person B. And it doesn't know which one's a computer or which one's a person, like there's a screen or something's blocking them off. And person C is passing messages to the computer A and person B and is receiving answers from person A and computer A and person B. And when those answers come back, if person C can't tell the difference between the two, then we've arrived at artificial intelligence. So, anybody here use ChatGPT, Bard, Anthropic, any of those? Come on, I know that's how you write your papers. Oh. It's not a secret.
They don't have papers.
They don't have papers anymore.
They actually have assignments where they use ChatGPT.
See, that's smart. That's exactly what I said they should do from the beginning, is this is a tool you're going to be using throughout your life, right? And it's in its infancy now. But are there times when you can't tell the difference? Like you would say, if I, other than the fact that like you actually get an answer, is it sometimes difficult to see the difference between the two? No, you always know. This is you're dealing with the computer. So, you don't use them. Okay, so like but that's the idea between artificial intelligence. So there are all kinds of problems with this. So first of all, let me just go through a couple of problems I have. If you think about it, it's a bit of a tautology in the way it's defined. If a computer acts like a person, then that computer is artificially intelligent as a person. It's sort of a circular definition, right? A tautology. If I have many artificial intelligence systems were not designed to communicate with humans in any shape or form. They were designed to do things like fold proteins or something along those lines. And so their input and their output are easily distinguished from a human interaction, but they would fail the Turing test even though they're doing something that is really super intelligent. So is that artificial intelligence or not? I would argue it is, depending on kind of how you define it. So there are a number of other problems with that. But one of the people who was thinking about artificial intelligence, who had read a lot of Turing's work on this, was a man named Marvin Minsky. And he was actually in a research facility, and he was watching rats learn how to navigate through a maze to solve a maze problem. And he was on the electronics and mathematics side of things. And he said, I think I could teach a machine to do that. Like, those rats can't be smart. I think we've learned, like, since then that rats are really smart. But, he was saying, I can teach a machine to do that. And so he built a machine to do just that. 1951. We've just arrived at 1951. This is Marvin Minsky, and I think everybody forgets the other guy's name. I think it's Dale Edmonds. That's probably wrong. But it's in my notes there, my page notes. And this machine was designed to navigate through a maze and to make decisions. Basically, do I go straight? Do I turn right? Do I turn left? Right? That was the range of its decision making, and it was supposed to learn from this. And this thing actually worked, or it did give output when inputs were given as to, they would take a piece, like a game of chess. You have the pawn. They would take a pawn. They would put it in the maze. They would advance it sort of one square, and they would tell the machine, what the options were. Is it open to the right, left, or ahead? And it would return with a response. Unfortunately, it never really worked that well. In fact, it was very difficult to distinguish the responses they got from this machine from just random choices rolling in dice. There was never any real learning taking place. But the reason that 1951 and this machine delineate artificial intelligence in my mind is that this was the first attempt to make a solution and to make a machine that actually had artificial intelligence. So they thought through what this would be. This is a dedicated neural network. You've probably heard the term neural network. We're going to talk a lot about that in just a minute. I've forgotten what this slide was about. So let's start going through kind of some of the thinking of artificial intelligence since then. So I think it's 1956. There were a couple of professors in the Ukraine that came up with a system of mathematics and for training a computer, a general purpose computer, so a digital computer, that would respond to different stimuli and come up with an answer, and that could learn. So they developed the mathematics behind this, and the math is like pretty intense. But that was the idea of how to train a neural network. 1979, in a lab at Stanford, was the first autonomous vehicle. And this is the first autonomous vehicle. It navigated across a room filled with chairs about the size of, half the size of this room, autonomously, without any sort of user input. And that was the first autonomous vehicle. So we're going back to 1979. But this is real artificial intelligence, an autonomous machine that can make decisions on its own. I did not have a rights-free image that I could use for this, so this one is actually the closest I could get. This IBM computer called Deep Blue in 1997 beat Garry Kasparov, who was the leading world chess champion. He was a Russian chess master at chess for the first time. And that was all in the news. So let's speed up, get closer to today. In 2009, Google actually started developing an autonomous car, and it had an autonomous car working. It wasn't perfect, but it was pretty good. It's the one with like the spinning thing on the top. You've probably seen it. Use LiDAR. And Tesla, in the same time period, started their autonomous vehicle, or started with autopilot. Now the full self-driving version of that. 2011. IBM's Watson defeated Jeopardy champions. There were 2 Jeopardy champions at the time. It's a game show, if you're not familiar with Jeopardy. But that was like the first time that it could respond. And it beat them so soundly, it wasn't even close. It was almost comical. And then in the 2010s, we get to the emergence of large language models. And we're going to talk a little bit more about large language models as we go through. So that's the general history of artificial intelligence up to this point. My journey was a little bit different. When I was a kid, my dad got me a computer, and they were so expensive, he rented it for 6 months from a friend. And it had a keyboard, it had 4K of memory, and I could load programs into the machine 2 different ways. One was through a cassette tape player. I don't even know if you guys know what that looks like, but a cassette tape player, and I would push the play button, and then I'd hit a button on the machine, and if everything went well and nothing, and my tape wasn't worn out, it would load a program into the machine, and I could save them by recording on the cassette tape player as well. It was a horrible process. The other way to get programs into the machine was I would go to B. Dalton Bookseller in the mall, and they had books of programs literally printed out, every line of code, and I could type them into the computer myself. And when the power went off while I was doing that, it was horrible. But one of the first programs that I ever typed into the computer was a program called ELIZA. Now, this was not really artificial intelligence in any way that we would think of as today, but it was sort of, advertised as artificial intelligence. So this was in the 1960s. This program was, or 70s. This program was actually written in the 1960s for a different machine, but I was typing in BASIC. And I knew enough about programming BASIC as a younger teenager, I was probably 13, 14 years old at the time, that I could understand what was going on. And I noticed that this program was nothing really special. It was a few if-then statements and some canned responses, and a very, very basic parser. In other words, if you type something in the sentence and it contained a word that it recognized, it would then send a response about that. But and it was supposed to be a computer psychologist. As you can tell, this was not a very good psychologist. If my therapist behaved this way, I wouldn't go back. But that was kind of my first introduction to programming and the idea of artificial intelligence. Then in the 90s, I think I told you I was working for Pizza Hut, and I was actually in charge of what we called then the database marketing program. And the database marketing program did 2 things. So one, we based it on your purchase history. So one of the nice things about working at Pizza Hut was we had an advantage over other companies, and I'm not saying over other pizza companies, but other retailers and restaurants, is that we knew who you were because you called in from your home phone, the one that was on the wall, right? And so we had your phone number, we had your address, and we knew how often you purchased. And we tracked your purchases as a convenience to you because we could say, hey, you want to just get the same thing you ordered last time, right? So I had tons of transversal data on hundreds of millions of consumers. And we could recognize patterns. So my predecessor at Pizza Hut, the one who invented these programs initially, created two programs. One would print out a coupon on the back of your receipt, which was called a bounce back coupon. And depending on like how often you purchase, et cetera, we would give you one of 5 different coupons. So, if you were highly motivated by deals, then we would print out a coupon with a deep discount. If you liked new things or like to try new things, then we would print out something like breadsticks or chicken wings or whatever, right? So it's a very different kind of marketing than other people were used to. We also had another program. And this other program, we would actually call you on the phone. And so we would figure out, we would take, and by the way, this is done in e-commerce all the time currently, right? Pre-e-commerce, well, or was it e-commerce? It was on the phone. Anyway, this was done, we would call you on the phone and we would offer you a really deep discount. So we would do this for people who had been heavy purchasers for a 3-month period and then had been non-purchasers for the next 3 months. And so we had these cohort groups, and once we hit that 90 days when you had no longer purchased, then we would give you a call and give you a really great deal and actually help you place that order over the phone right then. And you could, if it was a Wednesday, you could take delivery on Friday or whatever. So we had these two programs based on customer data. And we defined the cohorts, or these cohort groups, based on their purchasing frequency. So, like if I was, is this? No. There we go. The laser doesn't work that good. If I was purchasing a lot, I was a heavy purchaser, the guy over on the left, right? If I never bought, I was on the right. So I had these 4 different groups. Then I had moderate purchasers and I had light purchasers. Those were the segments that we had created in order to figure out whom to call, right? But the math kind of wasn't great because let me give you a scenario. You purchase a pizza every Friday for 90 days, and then you don't purchase a pizza for the next 90 days. You were in, right? You were in. Now, but what if you purchased a pizza once a week for a 90-day period, and also on the 91st day? So now you've made a purchase in the no-go zone, right? And so you're now a light pizza purchaser in that time period. You don't get a call, and you don't get the discount. But it's just one day. If you had made your last purchase the day before, you would have gotten a call, right? But because we were using general statistics, we didn't really have a better way or the computational power to go back and look, for hundreds of millions of records, go back and look at, what had been purchased. And remember, this is computers in the 1990s. So, but do you think there would be any difference in the behavior when I called them on the phone, and any difference in the business result for that one day of purchase? I don't know. I'd never find. I could never calculate that. Well, fortunately, this is a picture of my dad, by the way, who was a rocket scientist, and I don't say that figuratively. My father, and that's why I showed him with his rocket. My father was a rocket scientist for Raytheon. And he had a PhD, and math homework was a nightmare in my house because I would have trouble with my math. I would go home to my dad, and my dad would explain it to me, and his PhD level, voice and computation to a 14-year-old teenager. And I would just say, "Oh, thanks, Dad," and then I'd go figure it out myself, right? Because I didn't understand anything he said. And I feel bad for my sister, who was even worse at math than I was. But he introduced me to a concept called fuzzy logic, because I would call him up. So I was now in my 30s. I was no longer trying to get math lessons from him. But I would talk to him about some of the things I was doing at work, and I explained this problem to him, and I said, I don't think this is right. I think we're leaving money on the table, because Pizza Hut and PepsiCo was trying to get me to figure out how to make more money from this program. I said, I think we can make more money if we could figure out a better way to classify these people because of these, edge cases that I talked about in purchase behavior. And so fuzzy logic is based on the idea that I don't have to draw a line. Somebody can be a member of more than one group at the same time. And so you judge, well, how much of a heavy purchaser is this person, or how much of a moderate, or how much of a non-purchaser is this person? And is there a difference between a 1% non-purchaser and a 99% non-purchaser? So we can assign people by using rules that are fuzzy, right? And create a marketing program behind that. So just imagine that you work in a pizza shop, and it's your pizza shop, and you work there all the time, right? And so you kind of know your customers. And you decide that you're going to apply Pizza Hut's program to your customers. Well, you don't have the computers, and you don't have people's phone numbers because they come in, but you recognize them, right? And so when you see somebody that used to be a really good customer, and then you haven't seen them for a long time, maybe you give them, free breadsticks, or maybe you give them a special offer, or maybe you even call them up and you look them up and goes, I want to get this guy, right? So you're trying to solicit business based on your understanding and your intuitive assessment of what kind of customer they are, right? Well, fuzzy logic allows us to do this, and I'll walk you through the process real quick. The important thing is the fuzzy logic rules. So I have some hard data because at Pizza Hut, all I have on people is hard data, right? And so I have variables that come in and they are numbers, right? But I can fuzzify those numbers and I can say, well, this person's mostly a really loyal purchaser, or this person's mostly moderate or mostly light purchaser. But sometimes they're hard, sometimes they're light. So there's maybe 75-25, right? I can draw these conclusions, and what I do is I fuzzify those variables, and I put them, and I create what's called a fuzzy input. So then I create my fuzzy logic rules, and one of the great things about fuzzy logic is that I can use intuitive rules that you're used to using in, like, you could speak the rules, right? And make them that way. You can say, if somebody's been a really good customer for a long time, but I haven't, or a really good customer for quite a while, I haven't seen them in a long time, I'm going to make them a special offer, right? Like, that's marketing speak, right? The merchandiser, like, you get that intuitively. Of course I want to do that because I want this person to come back and buy more stuff. Well, in fuzzy logic, I can write my rules that way. And I can apply my rules that way, and I won't go through the math, I promise. But I come up with what's called fuzzy results, right? And so but the computer needs hard data to work on. So I defuzzify my results, which comes into now hard variables, and now the computer acts on those. Like the logic in my system, it either gives them a call or sends them a coupon or whatever it is that I'm doing at the time. So, but the beauty is I can think of, because of the fuzzification, I can think of my customers as, kind of not necessarily one thing, right? They can be different things at different times, and I don't have to draw a line. I can have, they can be mostly part of this group or the other group. And so I can go to a marketing person and explain this to them, and I don't have to tell them any math. I'm just saying, hey, what kind of rules do we want to impose? They can tell me those, and I can actually write those you can actually write that into the computer exactly that way. So I started to apply the fuzzy logic rules to the math problem that I was given. The other advantage of fuzzy logic is once I apply my rules, I output the rules into a lookup table. So those hard variables coming in, which we saw here, and the hard data coming out is just me, going along the x-axis and saying, this is 0.75, and this is 0.52, and then I see where those intersect, and that gives me a hard result, And so this type of application is very, very concise and very easy to run, and it doesn't take me a week to run that kind of calculation on 100 million pizza consumers. It takes me, 5 minutes to complete the whole thing. So it has all these advantages to it, but you're training a model based on human way of thinking about things. And that was one of the first types of artificial intelligence, was fuzzy logic. Let's take this down to e-commerce. So let's say that I run a t-shirt shop and I want to start selling hoodies, and I know that if I sell my hoodies to, or I want to try to sell my hoodies to people in my t-shirt shop. Well, let's say I sell in the US and Canada maybe, right, nationwide. If I've been selling hoodies, who do you think would be a good candidate to, or I've been selling t-shirts, who would be a good candidate to buy a hoodie? Who should I advertise my hoodies to? College students, okay, I like that. Young people, okay. Would it matter where people live?
Colder weather.
Yeah, colder weather. Okay, so like people that have like a team affinity or something like that, or? Okay. Any other way that I could define my potential hoodie purchasers from my t-shirt shop? Okay. I could either set up standard product relations in my store, and have you guys been enough in e-commerce that you know what I'm talking about, a standard product relation? It's like on a product page when you're shopping, if you buy this, you might also like these other items, right? That's a standard product relation. Another way is I could program a neural net to do this, but the problem with the neural net is it takes a ton of data to actually program a neural net. We haven't talked about them yet, but we will. We're almost at the end, aren't we? Or I can apply my fuzzy logic model to it. So basically, I know that when I apply my logic models to this, I'm going to end up with a place. I'm either going to give them a pop-up, I'm going to cross-sell in the cart, I'm going to make it related item or confirmation page only, and I can come up with basically my rules, right, for that. And these I would fill out the rest of these, and then now I've got my grid. And so I define my fuzzy variables, I encode the fuzzy rules, and I'm applying my fuzzy logic. And the beauty of this is this could actually run in the browser very simply, so I don't have to have any interaction, which is great. It's a very small lookup that I could do in e-commerce. All right, so I'm going to go through semantic search really quickly. So semantic search is a different type of search. And by the way, fuzzy logic and semantic search are all part of large language models, which we'll get to at the very end. But semantic search basically takes a piece of text and turns it into a bunch of numbers like this. It's called vectorization or codification. And if I map this out in a chart, those numbers look something like this. And they kind of have a shape to them, and you can see these spikes in meaning at different points. And so when I have two vectors that are similar to each other and their shapes are close enough, then I have a really good match. And the beauty is it matches on meaning. So I could have my input in English and my output in Russian. It wouldn't matter because I've actually used the same sort of encoding logic to create that. So semantic search takes your text and creates a table out of that text. And then during the search, you enter your search term, it vectorizes it, turns it into those numbers, right? And then it summarizes it, and I have matching on my table, and I get the results from it. There's like billion-dollar algorithms that are involved in both encoding and matching and searching on this. But this is how semantic search works. And semantic search allows me to search for items based on intent or meaning rather than a specific text. Does that make sense? So that is what vectorization is, and it's critical to it, and it kind of follows this logic of relationships between words. And these are kind of two classic examples that are used in semantic search. All right, so let's talk about machine learning real quick. We'll skip over some of this. Does anybody know about like the dog problem in artificial intelligence? So one of the first problems that neural networks approached was if they could, they said, well, we'll know like it's smart if we can tell a dog from a wolf. And so this happened in the 2000s. Everybody had these huge sets of data where they were training on, and and I'll tell you how the training happens in a minute. It's very simple. But but what they found out was it thought, like, is this a dog? This is a dog, right? It's a husky, right? This is a wolf in the wild. It kept thinking that the husky was a wolf, and they couldn't figure it out. Because they would train the model, and because the neural network model is a black box, meaning you don't know what's happening inside of it, despite attempts to remedy that, whenever there was snow in the background, the system thought it was a wolf. And so that's what they figured out. So you have to have a training set of data that is large enough and diverse enough to come up with good results when you're training a neural network. And what happens in a neural network is basically you create two inputs, they go into the what are called nodes, input nodes of the neural network. They actually output a number based on that input that looks like the semantic search vector sometimes. And then those are passed on to the next node. And you can have many nodes, tall and deep. I can't remember, like, ChatGPT is like, the training net is, I don't know, 16 billion nodes or something like that. No, I have it. It's 35 billion nodes. It has 70 billion parameters. Actually, that's the Llama 2 set. Anyway, there are billions and millions of parameters in the neural nets we have now, so much larger than this. But eventually, like, their inputs feed each other, and they create an output. And the way that I first encountered it, because my son, Giancarlo, who went to school in Hawaii and studied computer science and surfing, and not necessarily in that order, he figured out a way to predict waves using the wave conditions at the beach using a neural network. So, kill two birds with one stone, finish your AI assignment. But you have to train the model to make this work. And so one of the things that these models do really well is they classify things. So this is like classic sentiment analysis. You want to know if somebody's saying good things or bad things about you. Well, the neural node is basically, you can think of it as a math machine. It's got inputs coming in, and you apply these weights to the inputs, and then you apply a function to them. In this case, we're just adding them together, and you come up with the output. So 12 and 14 gives me 12, and 24 gives me a result of 14. In this case. But this node, every time you feed data through, it's going to apply these weights to the inputs, and it's going to create an output. It's that simple. It's not like that difficult. The hard part is when you're training a neural network, you give it the answers and the questions, and it works backwards and figures out what those weights should be. So I take 80% of my data set, I feed it into my neural net, it outputs it, until it gets the right answers. It keeps adjusting those weights until it's almost always getting the right answers. And then when I get the right answers, it spits out a model. I say, save that. It's what's called the parameters. I'm going to save the parameters. I'm going to spit out a model. And then I feed that 20% I held back. So the model has not been trained on it. It's new data for the model. And I see if it does a good job. And if it doesn't, I either improve my training data set, or I get it more nodes, or, like the data scientist has a few options at that point. Or I create new ways to actually train the nodes themselves. But that's how I train a neural net. And large language models, at the core, are just neural nets. Has anybody ever said thank you to Alexa, by the way? When you say thank you, say thanks, Alexa.
Occasionally, my parents have one.
You say please? Alexa, please? No?
I say please, but I say thanks.
You ever screamed at your Google Home?
My dad has.
Okay. This guy is screaming at Jexy. I don't know if you remember that movie. But if you get mad at an inanimate object, I feel like it's probably an AI-empowered inanimate object. So training LLMs takes a lot of information. So we showed that little bitty thing of nodes. They compress 10 terabytes of text from the internet. It could also be images. They train it for 12 days on 6,000 graphic processors at a cost of about $2 million over those 12 days, for these large language models. And it spits out about 140 gigabyte file. This is kind of like when we were talking about our fuzzy logic. This is like my table. This is my lookup table. Now, it runs through about 500 lines of code, but that's not a lot of code. When I take my inputs, the neural net processes it, but it takes 140 gigabytes of parameters, so about 70 billion parameters. That's for the Llama 2 model, which if you want, you can download and play with it yourself. But large language models at the center have a neural network, and they expand upon it. So the neural network is mostly for communication with the end user, and then it has resources it can draw upon. So it knows when you're asking it a geography question, it may open up a browser, go to Google Earth, pick up the, it does what you would do in the very same way. It may access other large language models. It may open a calculator. If you tell it, what's 5 plus 10, it's just going to open up a calculator. Sometimes it has to write some Python code in its terminal and execute Python code, but it will actually do that, right, as a large language model. So it's multiple neural networks essentially working together with external components. But basically, the large language model that you're used to working with is simply a way of understanding what you want and asking it. And they're not very good. Right now, GPT-4 is a C student, maybe a B student. Let's go to my final example, and then we'll go through some questions. Let's say about Alice. So Alice graduated from UNT, and she worked for me for 4 years. Let me give you a day in her life. So she gets 1,000 products from a supplier, and she needs to get them online. And she's got a spreadsheet, she's got images, she's got all this stuff. She gets them in an email, and artificial intelligence makes sure that email gets to the right place in her inbox. So she's already used artificial intelligence before she even opened the email. She uses ChatGPT to make category assignments because half the products are missing a category. Very easy to do. I've done this. She uses Adobe Sensei to adjust the images because the lighting's not right. Adobe Sensei is another artificial intelligence product. She uses maybe Bard to adjust descriptions. I don't know why Bard, whom I think is like sort of the village idiot of the AI, is pretty good at language. And then she uses ChatGPT to write short descriptions because 100 of the products had long descriptions, but they didn't have short descriptions. She uses all these things, and she gets these 1,000 products up by the end of the day. When Alice was working for me, that was at least a week worth of work. And I guess I can now take this helmet, and I won't read you the whole thing. I just gave ChatGPT my client's helmet image, and it wrote the product description for me. I edited maybe 5 words in that product description. Whereas if you had to write that from scratch on your own from an image, it'd be crazy, right? So I guess what I'm saying is, it also makes nice life photos. We call a new phenomena by a specific name until they become ubiquitous. Who refers to your phone as your smartphone? Nobody calls it a smartphone, right? It's your phone, right? But we used to call it a smartphone, and now we just call it a phone again. And that happens through all these things. So for AI, as we use tools that include AI, including your phone, you don't call it your AI smartphone, whatever, right? It's just your phone. And artificial intelligence is built in. And this is not going to happen overnight. If it happened overnight and the machines took over, we'd have problem, but they've got a lot of issues. And my main prediction is that you're going to be fine. So going back to Armageddon, there's no Armageddon. You have time. You were born, and I say born, you started your college career and your e-commerce studies. You were already surfing the wave. You just didn't know it. You were surfing the wave of artificial intelligence, right? It's part of what you do. It's become part of who you are. And all these people that are saying, oh, it's going to take over the world, and it's going to do this, it's going to put everybody out of jobs, don't believe it. Don't believe it. You are going to be fine. Learn to use artificial intelligence tools the same way I learned to use the internet, right? When I was coming up in your age. We had no idea, right? And everybody thought it was going to take away our jobs. But what happened? It created more jobs. You know, according to the World Economic Foundation, which whatever you think of them, they think it's going to create far more jobs than it destroys. And that's one thing I agree with them on. Thanks for coming. Really appreciate it. Anybody?